right, so today we're going to talk about mean absolute deviation. This is part 1 of your reteach for data. So Bill wants to estimate the number of minutes students spend waiting for the bus each morning. He decides to take a random sample of 10 anonymous students. The results are shown. Determine the mean absolute deviation of the data set and explain what it means in terms of the problem situation. Whenever you are given a dot plot, the very first thing you need to do is write out all of your numbers. So I have one x above 4, I have an x above 5, 6, 7, 8. I have 2 dots above 9, so I'm going to write 9, 9. Then we have 10, 12, and lastly 18. Okay, so step 1 in finding mean absolute deviation is obviously we have to find the mean. To do this, I'm just going to add all of the numbers and divide by the number of numbers I added. So we have 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 9 plus 10 plus 12 plus 18. That gets me a total of 88. And I added 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So divide by 10. And the mean is equal to 8.8. All right, the next step in finding mean absolute deviation is to subtract the mean from all of the data points. So we have 4 minus 8.8, 5 minus 8.8, 6 minus 8.8, 7 minus 8.8, 8 minus 8.8, 9 minus 8.8, 10 minus 8.8, 12 minus 8.8, then we have 18 minus 8.8. Notice I left the 8.8 as a decimal. When it comes to mean absolute deviation, you are not rounding, okay? You need to leave the mean in its entirety. So now I can just use my calculator and do the subtraction. So 4 minus 8.8 is negative 4.8. 5 minus 8.8 is negative 3.8. 6 minus 8.8 is negative 2.8. 7 minus 8.8 is negative 1.8. 8 minus 8.8 is negative 0.8. 9 minus 8.8 is 0.2. 10 minus 8.8 is 1.2. 12 minus 8.8 is 3.2. And 18 minus 8.8 is 9.2. All right, the next step for mean absolute deviation is I need to make all of the values that I just got, all of the deviations, positive. So I'm going to change negative 4.8 to positive 4.8. Negative 3.8 becomes 3.8. Negative 2.8 is going to become positive 2.8. Negative 1.8 is just going to become 1.8. Negative 0.8 is just going to become 0.8. And then all of the rest were positive, so I'm going to leave them as they were. Okay, I now have the absolute value of all of the deviations. Mean absolute deviation, well, that tells me I need to take the mean of all of my absolute deviations. So again, we're going to add all these numbers up and then divide by the number I added. So 4.8 plus 3.8 plus 2.8 plus 1.8 plus 0.8 plus 0.2 plus 1.2 plus 3.2 plus 9.2. Oops, I think I added something wrong here. Let me do it again. 4.8 plus 3.8 plus 2.8 plus 1.8. Oops, that's a 7. Maybe that was my mistake. 0.8 plus 0.2 plus 1.2 plus 3.2 plus 9.2. 4.8, 3.8, 2.8, 1.8. The reason I'm a little shocked here is earlier I got 28. So let's see if I can find my mistake. 9.2, 3.2. Ah, here's my mistake. How many 9s did I have? I had 2 9s, so I forgot to do my second 9 minus 8.8. Always double check your numbers. So now if I add that extra 0.2, yep, I get 28. So I got 28 when I added them all up. I added 10 numbers, so I need to divide by 10. That's another easy way to check. I need to be adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, the same number you added for the mean. 28 divided by 10 is 2.8. So that means my mean absolute deviation is 2.8. Now, what does that mean in terms of variability? Well, 2.8 is very low for a mean absolute deviation, so that means low variability. Remember, mean absolute deviation and variability are the same thing. So the Paletti and Singh families each have 5 children. The names and ages of the children are given in the following data tables. Which family's children are closer in age overall? Explain your reasoning. Well, just looking at the tables, I'm probably going to guess that the Singh family is a little bit closer together in age because all of their ages seem to be tighter, more compact, whereas this one has a 14-year-old and 2 3-year-olds. But to verify that, I'm going to need to find the mean absolute deviation because we're talking about variability. If they're closer in age, there's not a lot of variance. So step 1 is to find the mean of both of these. So I'm going to add all of these numbers up and divide by 5. So 14 plus 6 plus 9 plus 3 plus 3 is 35. 35 divided by 5 is 7. Then we have 11 plus 12 plus 9 plus 12 plus 6 is 50. 50 divided by 5 is 10. Next step in finding mean absolute deviation is to subtract all of these by the mean. So minus 7, minus 7, minus 7, minus 7, minus 7. 14 minus 7 is 7. 6 minus 7 is negative 1. 9 minus 7 is 2. 3 minus 7 is negative 4. Okay. Then we're going to subtract 10 from all of these because the mean for this family was 10. So we get 1, 2, negative 1, 2, negative 4. Now again, we need to make all of our deviations positive. So I'm going to change this negative 1 to be positive 1, and these two negative 4s to be positive 4s. This negative 1 to be positive 1, positive 4. And now to find the mean absolute deviation, or the MAD, I'm going to add all of the deviations up and divide by the number I added. So for the first family, we're adding 7 plus 1 plus 2 plus 4 plus 4. I got 18, and I divide by 5. So this mean absolute deviation is 3.6. For the next one, we're going to add 1 plus 2 plus 1 plus 2 plus 4. And that gets me a total of 10. 10 divided by 5 is 2. So the MAD for this one is 2. We were right. The Singh family has all of their children are closer in age because they have a lower mean absolute deviation. All right, our last practice problem is Wally is practicing to run a quarter-mile race in an upcoming track meet. He wrote down his times in seconds during his practice. His data is shown. What is the mean absolute deviation? All right, as always, step 1 is to find the mean. So I'm going to add all of these up and then divide by the number I added. So we have 65 plus 92 plus 71 plus 83 plus 86 plus 69 plus 79 plus 90. That's 635. I added 1, 2, 3, 4, 5, 6, 7, 8 times. So I'm going to divide by 8. And I get 79.375. Like I said before, we're not rounding these numbers. Okay? Not until the very end at least. So I'm going to keep that all the way out those 3 decimal places. So now I need to subtract the mean from all of the data points. So we have 65 minus 79.375. 92 minus 79.375, 71 minus 79.375, 83 minus 79.375, 86 minus 79.375, 69 minus 79.375, 79 minus 79.375, and 90 minus 79.375. All right, I'm going to use my calculator and go ahead and subtract all of these. You always have a calculator, so there is no reason why we can't do these decimal subtractions. So 65 minus 79.375 gets me negative 14.375. 92 minus 79.375 gets me 12.625. 71 minus 79.375 gets me negative 8.375. 83 minus 79.375 is 3.625. 86 minus 79.375 is 6.625. 69 minus 79.375 is negative 10.375. 79 minus 79.375 is negative 0.375. And lastly, 90 minus 79.375 is 10.625. Oops, that's a 10. Again, I'm going to make all of these deviations positive if they are not already. So this negative 14.375 becomes positive. Same thing with the negative 8. And the negative 10. And the 0.375. Now I'm going to add all these numbers together, and then I will divide by the number of numbers I added, which should be the same number I divided for the mean. So 14.375 plus 12.625 plus 8.375 plus 3.625 plus 6.625 plus 10.375 plus 0.375 plus 10.625. I get 67, and I added 1, 2, 3, 4, 5, 6, 7, 8 numbers. That's the same I got for the mean. Divide, I get 8.375. So from my answer choices, the closest one was 8.4. We're not rounding until the very end, and you're only rounding if the multiple choice answers ask you to do that. All right.